طيب, بسم الله الرحمن الرحيم. So we stopped last time talking about adaptive and non-adaptive, and we said that for adapting to quality of service degradations, some applications are more tolerant than other applications, and we said that adaptation could be classified into two types: the rate adaptive and delay tolerant adaptive, or delay adaptive. For rate adaptive, we have two things we need to discuss here. There is, first we have to know what triggers the adaptation, and then once we get the trigger, how do we react to that? Okay. So as we said before, the trigger comes from either the network or the receiver. So usually the sender will send with a specific rate, but if it gets a feedback from the network that maybe there is some kind of congestion or something, then the source or the sender will adapt to this and will try to lower the rate or try to shape the traffic somehow in order to control the delay. Okay? So this is the trigger. So the trigger may come actually from the network or may come from the receiver if the user who's watching a video or something, he can just based on the speed of the network, based on his knowledge about the data plan that he has or something, he can just lower the rate by selecting lower resolution video, which is some of the features that we have in YouTube or any video streaming tools. So this is the trigger. So what triggers the source to adapt the rate may come from either the network or the receiver. So the other thing is that, okay, so when we get the trigger from the network, how do we control the rate? So or the delay. So we can do this by either we have to shape the traffic. So regardless of the packets that are coming from the encoder or from the camera or something, we have to make sure that we send the traffic with a specific shape, so that we make sure that the traffic will go smoothly through the network, which may involve actually lowering the rate. And it may in some cases involve even dropping some packets. Okay? So traffic shaping is an area that we will study later. So the source may actually control the rate through controlling or through restricting the transmission rate, or in some cases through dropping some packets. Delay adaptive may be controlled, as we said before, either again by traffic shaping. So by controlling the rate, in some ways we actually control the delay, because if we send with very high rate, what we essentially do is that we contribute to more congestion on the network, which will add some problems in the network, and therefore the delay that will be introduced to the packets may increase throughout the time, and that will introduce some delay variation which may not be tolerable by the application. Another way of controlling the variation in delay, as we discussed before, is the de-jitter buffer. So for de-jitter buffer, we introduce an initial delay, but with the hope of having like some controlled delay variation between the packets after that. Okay. The third category or the fourth category is the application or the fourth factor based on which we design the quality of service, is the application criticality. And we talked about that before. So this reflects the importance of the application, or the importance of how to use that application. An example is remote surgery, and that does not necessarily depend on the type of information that we are sending. Remember that. So remote surgery, it does not involve any video transmission, or it may in some cases, but it may not actually involve some video transmission. Yet you need to control the delay very drastically, because any kind of delay can become fatal to the patient. Another example, which again does not involve video or something like that, which is very sensitive in terms of delay. We know that video intrinsically is very sensitive in terms of delay, which is money transactions. So money transactions is another example. Third example is telemedicine. Well, telemedicine is very broad, but some applications that involve, for example, detecting patient condition, like, for example, heart attacks or seizures or something. So these are fatal conditions on that the patient may have at any point in time. And if he does not get the help right on time, he may actually die. So in that case, this type of application is very, very much critical, and it's very much delay sensitive, regardless of the vital sign that we're using. Vital sign may be like ECG or EEG or whatever vital sign we're using. So in that case, it's very critical. Non-mission critical applications are usually more tolerant to delays and to other things. Okay. So the main message here is that the criticality of the application does not necessarily depend on the type of information that we send. Okay, it's coming from the inherent functionality of the application and the criticality of the use case that we are using. Okay, type. So this is so the requirements of the quality of service requirements of the applications are affected by what we have talked about, the criticality of the application and the amount of tolerance and the type of information that we are using and so on. So now, how do we quantify that? Okay, how do we quantify this quality of service? So basically, we use the four metrics that we have talked about. The bandwidth or the throughput. Bandwidth and throughput are usually used interchangeably. So bandwidth or throughut, delay, packet loss, and jitter or delay variation. So these are the four metrics that we talked about. So the quantification of this quality of service is actually represented by specific values that we give to each of these metrics. Okay, and we could actually use maximum values, like we say, okay, so this application requires or constrains the delay to be 500 millisecond at maximum, which means that if we give that application 400 millisecond as an end-to-end delay, this is good. So the application should not complain. But if we give 600 milliseconds, so that may be a problem for this application. Okay. Same thing applies for throughput and so on. So for example, for bandwidth, we may actually restrict the minimum bandwidth, or we may actually restrict the average bandwidth. Okay. For delay, we either restrict the maximum delay, okay, or again we restrict the average delay. So when we restrict the minimum throughput or the minimum bandwidth, this means that if the application gets resources from the network that guarantees a bandwidth more than the minimum bandwidth, then we're fine. Okay? Less than that might be a problem. Okay? So less than this bandwidth, it will be a problem. Because bandwidth is the bottleneck metric. Delay, unlike the bandwidth, which is the bottleneck, so bandwidth is like, it's actually represented by the width of that pipe. Okay? Delay is different. Delay is affected by the how many stages the packet will go through. Okay? So bandwidth or the throughput is restricted by the tightest part of the pipe. It's like, imagine like you have a water pipe. So if we have water flowing through a pipe, okay, so the flow rate is restricted by the tightest part in this pipe. Okay, Delay is affected by the distance or the how many stages that we go through, because each part in the network introduces end-to-end delay, right? So the more stages you go through, right, the more delay gets introduced to each packet, right? So that's why a bandwidth is a bottleneck metric, whereas delay is an end-to-end metric. So it's affected by how many stages you go through. If we usually, in constant bitrate applications, in applications that inherently use constant bitrate, we usually have one metric, or sorry, one value on each metric, okay, which is the average rate. So we say that we guarantee an average throughput for this application, which is, let's say, 1 megabits per second. Which means that from the network point of view, I need to maintain an average rate of 1 megabits per second, which means that throughout the time, if we calculate the throughput versus time, it may be, well, we're talking about constant bitrate, but it's maybe from the network point of view, it may go up and down like this. So the variation is not that much. But as long as the average is 1 megabits per second, then we're fine. So the guarantee or the quality of service guarantee in that case is 1 megabits per second on average. On average. So it may go up or down, but on average you can maintain 1 megabits per second. Okay? For variable bitrate applications, usually one value is not enough. Because the variable bitrate applications, usually the variation in terms of bandwidth is high. Okay? If we maintain only average throughput, that might affect the application, because the application may send like a huge amount of information in a short amount of time, right? And then after that, it may send a few packets in a long time. So the amount of data that gets sent in a duration of time varies a lot. Okay? So in that case, if I say maintain the average, this means that when I send bursts of many packets back to back, the network will not be able to handle this. Which means that the network will delay these packets, which will result on the receiver side to bad quality. Okay? So we cannot just say that by guaranteeing the average throughput or the average delay is that we can maintain constant quality for variable bitrate applications. And here we're talking about variable bitrate applications. Variable bitrate applications like what? As we said, video. Video inherently is variable bitrate. In compressed video, compressed audio is variable bitrate application, right? Why? Because the way we encode the compressed video is by leveraging the notion of the fact that from one frame to another, the change is not high. Like if a person is walking and I'm taping that person while he's walking, the background does not change much, okay? And the variation is introduced by the fact that he or she is moving. But the change from one frame to another is not that much. So what happens is that we encode that difference and we benefit from the fact that the difference is not high to compress the video more, okay? Which means that the first frame has to be sent completely, and then I send only the changes. And maybe after some time I need to send the full frame and then send the changes. Something like that. So that actually results into a variable bitrate from video to send huge amount of information in short amount of time when I try to send the whole frame. And then when I send the differences, I can encode the differences to using like few number of packets. So this results into a rate which goes really high, and then it goes low, and then it goes high, and then it goes low. So if I want to maintain constant quality on the video, I need to guarantee this variable, this variation in the throughput from the network point of view. And that's the challenge. This is a real challenge. So only guaranteeing average throughput or average delay for variable bitrate applications may not be enough. Okay? So we need to guarantee certain maximum or minimum, like maximum in the case of delay and minimum in the case of throughput. So for variable bitrate applications, very commonly you see that we need a minimum bitrate of 2 megabits per second. This means that you can send 2 megabits per second without introducing that much delay, and you can send them smoothly. But the problem is that for variable bitrate applications, the variation in the throughput is really high. So the network cannot change the resources up and down like this, right? So that's why it's really challenging, because the network, you have to control all the routers on the path. You have to control so many things. You have to control the whole hardware to guarantee this variation in delay to go up and down, which is really challenging. We cannot do this. We only can guarantee some throughput on the router for a reasonable duration of time. So that's why the variable bitrate applications are very, very challenging to guarantee quality of service for. So usually you need many components to work together. So you need traffic shaping from the sender, you need quality of service guarantees on the routers, and you need de-jittering buffers at the receiver. And you need all these components to work hand in hand in order to provide the best quality possible. It's not an easy job, okay? And we will see that it's not really straightforward. So that's why you say that for MPEG-4, we need a bandwidth from 5 kilobits per second all the way to 4 megabits per second. You see the gap? The gap is really huge, because MPEG-4 is the format of the compressed video, right? So the format of the compressed video can give you bandwidth of 4 or 5 kilobits per second all the way to 4 megabits per second. So the gap is huge. So if we want to guarantee 100% quality on MPEG-4, then the network needs to give 4 megabits per second in all times. Because to maintain this in a very short period of time is not possible. So we have to give 4 megabits per second. But is this really efficient? No. Because when the rate drops down, we're wasting bandwidth. So if we guarantee the maximum rate, then anything below that is waste, right? If we maintain the average rate, then anything above this will encounter delay. Okay? Same thing on the delay. Also, if we maintain the maximum delay, this means that basically the network is giving more resources to this traffic. So again, when the delay becomes more tolerant in some periods of time, then we're wasting bandwidth, or we're wasting resources from the network side. Okay? Any question here? So in other words, the application requirements are defined using what we call bounds. Bounds on each of these metrics, on the bandwidth, delay, drop, packet drop, and jitter. So the bound may be the maximum or minimum or average or both, right? So less than certain bound should be strictly followed in mission critical applications. So in mission critical applications, I may have to waste bandwidth because I have no other choice, because I have to maintain 100% quality. There is no discussion about this. There's no tolerance. I cannot just say, in order to maintain efficiency, I will give you average quality of service and the patient dies. In that case, it doesn't work. So we have to work on the highest bounds. For delay tolerant application, the bound is average delay bound. That's why we said that really for delay tolerant applications, we can tolerate maintaining average quality of service, right? Because average means that even if we're talking about variable bitrate applications, okay, this means that if it's above the average, you may encounter extra delay, but that's fine because this application is delay tolerant. Okay, so it's fine. And also, I can introduce some dejittering buffer at the receiver to smooth out this delay effect. So using that, I can also make the quality even higher. Okay. So for packet loss, for example, we sometimes maintain a statistical value. So this is different from average or maximum or minimum. This is different. Statistical value, this means that in 90% of the time, I need to maintain this much packet loss. 90% of the time. Which means that 10% of the time, it can increase more than that. مفهوم?
This is done by feedback? This is done by feedback?
Yeah, this is done by controlling the amount of packet drop. So 90% of the time, I need to maintain a drop rate of, let's say, 1 packet per second. Which means that in 1 second, if I maintain if I actually have 2 packet drops, then this counts towards the 10%, not the 90%. If the number of seconds that we maintain higher than 1 packet is more than 10%, then we violate the quality of service. So we need to maintain statistical bound on the packet drop, not maximum, not minimum, not average. It's a statistical bound. They call it a statistical bound. Okay, so 90% of the time, the maximum drop rate should be 1 packet per second. 90% of the time. Okay, and of course, the lower this number is, the more tolerant this application will be to packet loss. So if I need to maintain 1 packet drop per second 20% of the time, then this means that the application is really tolerant, right? Because other than the 20%, I can drop more packets. Okay. Usually, statistical type of bounds is the most challenging. It's really challenging to maintain. Because as you can see, it has some statistical components into it, and to incorporate this in a router and make it aware of the statistical packet drops is not an easy thing. Okay, so we talked about upper bound, lower bound, like maximum, minimum, average, or statistical bound. So for statistical, you have to maintain 2 numbers. For 20% of the time, the rate is this, or the packet drop is this. Okay? But for the other 80%, we don't have any control. We can actually introduce more packet drops. We can introduce less bandwidth. We can introduce more delays.
So the list is also considered as violation, right?
Hmm?
The list number of packets that's going to be dropped considered as violation from the 10%.
The more percentage throughout the time I have higher value of packet drop, then in that case I'm violating. Yani, let's say that So this is the time, and we have, let's say, 100 second. Okay, and the quality of service says that you need to maintain packet drop of maximum 1 packet per second for 90% of the time. So we divide this into seconds. Okay? Let's imagine that we divide this into seconds. We have 100 seconds. In the first second we have 2, in this second we have 1, in this second we have 0, 3, 0. Actually, this is a nice problem. We can talk about this in the exam. So 4, 6, 7, 0, 1, 2, and so on. Okay? So how do we evaluate whether this kind of packet drop from the network point of view, whether it violates the quality of service or not? Again, the quality of service is we need to maintain 1 packet per second, okay, for 90% of the time. So this is the quality of service maintained by, or it's represented by 2 numbers. We need to have maximum drop rate for a specific percentage of time. Okay, so this violates, right? So in that case, this violates. This one violates. This one violates. This one violates, and so on. If we count these, and we remember we have 100 seconds. If we get to 11 time slots or 11 1-second durations for which the packet drop is more than 1, then it's violation. So we count the number of seconds where we have packet drops more than 1 packet per second. Okay, if this percentage is 10 or more, then we are in violation. If we have this is 1, this is 0, and so on, and for each of the seconds during the entire 100 second duration, for each second we find that we have maybe 3 or 4 or 5 of the 1-second durations that have packet drop more than 1 packet per second, then we're fine. مفهومة ولا؟ لسه مش مفهومة. Okay, so as we said, we have 100 second time horizon. The whole time horizon is 100 seconds. Okay, and this is the quality of service that we have. At maximum, 1 packet per second, 90% of the time. 1 packet per second, 90% of the time. Okay, so either we say that we want to make sure that for the 100 seconds we have every second we have either 1 or 0 packet drop, and we count these number of seconds. If they are 90 or above, then we're fine. ماشي? So that's how it works. If it's 90 or above, then we're fine. What I'm trying to do is that I was trying to make it easier, because counting 90 is hard, but counting 10 is easier. So I count the number of 1-second durations that have more than 1 packet drops, because these are the time durations that are in violation of this constraint, 1 packet drop per second. If the number of these 1-second durations is more than 10, then we are in violation. If you go through the statistics course, it's much easier to calculate 1 minus p as opposed to p if p requires that you have to count so many sets or so many trials. So you count 1 minus p, and then to get to p, this is 1 minus the number. So this is what we call a statistical bound. Statistical bound. So we talked about bounds being maximum or minimum or average or statistical.
Calculating this, for example, it depends on the likelihood that the second will have these drops. Like for a specific channel that we want to calculate this is statistical value.
Right.
We need to encounter like experimental.
Yeah, of course, you have to do this through experiments. So what you do is that, مثلا imagine that you have your course project and you are sending some packets, and then you want to calculate this value, or you want to calculate the current statistical drop rate on your traffic. Then what you do is that you try to see the packets that you receive every second. Okay. And during this second, for example, you are supposed to receive 10 packets, but from the packet sequence, you have received first packet, second packet, and then the fourth one. This means that the third one has been lost. Okay, so in that case, you have a counter. You calculate the number of packets dropped during this second. Okay.
And we need to do this multiple times.
You need to do this, yes, during the entire second. So after 1 second, you reset the counter. Okay, and then you move to the next second. You have like 1 second window that slides over the time horizon. So in the first second, you're supposed to have 10 packets. So you receive the second one, and then the fourth one, and then the eighth one. So you calculate the missing packets. So during this second, there were like 3 packets dropped, or 2 packets dropped, or 1 packet dropped. So in that case, you calculate the packet drop rate against time. So the packet drop rate against time would look something like something like this, and then okay. So if you have this bound tells you that we need to maintain 1 packet drop per second 90% of the time. So this means that you have to put like a threshold on the 1 packet per second. Okay? Just the fact that you have packet drops higher than this, it doesn't necessarily mean that you are violating, because here we're talking about statistical bound. So we need to calculate this, and this, and this, and this. Okay? So you calculate the duration of all these times. If these times constitute more than 10% of the time horizon, then and only then you are in violation.
Doctor, I understand how we find if it's violation or not, but what's the meaning of the concept violation? What do you mean by violation?
Okay, that's a good question. If you are in violation, then technically you can sue the service provider. This is how critical it gets. Because, well, you have a service level agreement with the service provider, okay? And the service level agreement says that the service provider, who is actually maintaining the network, should guarantee for you this amount. Okay? So, as a business, of course, as users, we're always jeopardized. We're always guinea pigs. But we're talking about businesses and large firms. Okay, so if through some traffic profiling they discover that this quality of service is actually violated, then they can technically sue the service provider. They can change the service provider. They can do some actions. Okay, because this will reflect on the quality of the application. And the statistical bound is always coming from the fact that it's sometimes impossible to maintain, for example, availability for the system 100%. Even Facebook and YouTube, sometimes they go down. Okay, so in that case, we can always tolerate, مثلا, 1%. So the availability, مثلا, for YouTube is 99.9%, which means that 0.1% of the time their system is allowed to be down. So there is always that a statistical bound where you cannot maintain certain level 100% of the time. يعني زي ما بنقول كده بالعربي دوام الحال من المحال يعني. It's almost impossible to have something working and operational and maintaining certain bound 100% of the time. It's almost impossible. Okay, so that's why we resort sometimes to statistical bounds. Any questions? Okay. So this is what we call quantitative quality of service, and this is very important because this will stick with us throughout the course. Sometimes in some applications, we sometimes resort to qualitative expression. Qualitative expression. This means that we don't use bounds, we don't use specific values on the matrix. We sometimes say we need qualitative quality of service, in which case either we say bandwidth as much as possible, which sometimes is referred to as best effort. So best effort, internet in the past was actually best effort kind of network because it does not actually guarantee any quality of service. So in a way, it's qualitative. We cannot actually set bounds on the delay and bandwidth. We cannot, because in one day the performance may be very, very good, on another day it may be very bad. And there is no bounds set on the type of service that you get from the internet. So in a way, this is qualitative. We cannot set any bounds. Sometimes it's relative. So we know that some video applications, they have certain quality of service. So as long as I have better than this, I'm fine. So it's relative to something. So this is also qualitative. Again, in that case, we don't have any specific bounds. We don't have any quantities. But we have qualitative. So as long as I'm better than this, I'm fine. But again, in that case, going back to your question, we cannot set the boundary where we say, okay, we need to violate the service provider. It's qualitative anyway. We don't have any bounds based on which we say that you are in violation. You cannot say that. Okay. So qualitative expressions or qualitative quality of service is loose. Okay, is loose. So you cannot just say this is in violation because it's qualitative anyway. So why providing qualitative, or why talking about qualitative quality of service? Well, quantitative quality of service is too hard to maintain. Is just too hard, especially for variable bitrate applications, as we said. Sometimes it's just too hard for the network to maintain that. So many times the service provider cannot provide quantitative quality of service to all businesses and to all users. So in a way, even when we say that we have a 10 megabit per second plan, so the service provider says that. They tell us that, right? But you almost never get this. So in a way, it's qualitative, because if you actually calculate the amount of rate that you get as a throughput, you are always in violation. Almost always you are in violation, right? So for users, it's always qualitative in a way. Okay, but here comes the difference. The 10 megabits per second is better than 100, the 1 megabits per second, right? So this is what we encounter, right? So it's qualitative and it's relative. So at least we can, based on certain percentage of the time, we can guarantee that the 10 megabit per second plan will get a service better than 1 megabit. But both of them will be in violation. Okay? So this is qualitative expression, even though it's... so that's why, as users, we always strive to get the better plan still, right? Because we know that, at least relatively speaking, we'll get a better plan. But is this quantitative? No. This is not quantitative. And it's in many cases too hard to guarantee quantitative quality of service to single users. Okay? For big firms and businesses, yeah, it makes sense. So usually for service providers, they have a service level agreement, which is in many cases a very complicated legal document, which lists all types of bounds that you can imagine. Okay, and we always use statistical bounds because, as I said, it's almost impossible to guarantee this 100% of the time. You cannot. So this document always contains some statistical bounds on bandwidth, on delays, on packet loss, and so on and so forth. Okay? Any questions?
Still qualitative expressions, there is general space, for example, for describing, for example, bandwidth, the qualitative expression for bandwidth and delay. Like how do you describe it in a qualitative way?
لا هو يعني again usually for qualitative qualitative on the bandwidth usually there is no bounds, but why the service provider uses some specific number on the plan is just to distinguish, or is just to give you the message that the 10 megabit per second plan is always better than the 1 megabit per second. That's all. But that doesn't mean that it's actually a bound or it's actually quantitative, because it's not. They cannot provide quantitative quality of service for users. For businesses, yes, for sure. Because businesses, they are a big influence on revenue and things like that. And they always, for businesses, they provide services to others. So if you violate the quality of service, not only do you affect that company or that firm, you affect all the people that get service from this company. So the impact will be very, very high. So that's why in that case it makes sense to have some quantitative quality of service bounds. It makes sense. In addition to the fact that firms and businesses, they pay a lot, of course. So they need to get some bounds on the quality of service. خلاص, we'll stop.